Okay, so number 3 in our series. Got fractions involved. We've done the same thing. We've proved P of 1. Remember, must make sure that you say therefore P1 is true. We're assuming PK is true. And now we wish to prove that PK plus 1 is true. Okay. And this is where we're going to rewrite our question again. You're probably sick and tired of me saying this, but make sure that you do pop in your kth term. So this is the k plus 1, and now, right, so this is pretty much up to this point here, this is pk, but now we do the k plus first term. So what's the next term after the kth term? Wherever k is, we replace it with k plus 1. Okay, or I guess you're saying wherever n is, really, you're replacing it with k plus 1. So k plus 1 gives me k plus 2. And what do we want to make it look like? Okay, so we're putting in k plus 1 on the right-hand side. So that becomes k plus 1 on top. Underneath, we've got k plus 1, so k plus 2. So all your basic, step 1, step 2, we've put everything in. That's great. Here comes the actual maths where we want to prove this statement. Okay. We have, as we said before, this whole bit here. That is equal to your pk there. So I can replace all of it with that, which is exactly what we're going to do. So that becomes k over k plus 1, but then we have to add our k plus first term, which is this one here. Okay, so 1 over k plus 1, k plus 2. And we want to make it look like what we've got here, right? That's our goal. We're aiming for that k plus 1 over k plus 2. So we look at what we have, and we've clearly got fractions. How do we add fractions together? We want to get a common denominator. Now we can see, we could just times the denominators together, but we can see that both of them actually have already the k plus 1 there, okay? So that means we want to have our common denominator of k plus 1, k plus 2. So in order to do that, I have to multiply this other one by k plus 2. And of course, what I do to the bottom, I'm also going to have to do the same to the top. So here we go. Let's just have a little bit more space. It gets really squashy with fractions. So my common denominator is now the k plus 1 times k plus 2. There's a little bit of concern because what we're looking for here is not k plus 1 times k plus 2. So hopefully things will cancel on the top. All right, so what did we say? We had to times this one by k plus 2. So we end up with k times k plus 2. And what have we got on the right? The plus k plus 1, because that already had our denominator that we wanted. So we didn't have to times that by anything. Okay, let's tidy up. K times k, we have k squared, right? We're expanding our bracket. Plus 2k plus 1. Denominator stays the same. We look at the top, and lo and behold, we can factorize that. That's a perfect square. So we end up with k plus 1 times k plus 1 all over k plus 1 times k plus 2. And wouldn't you know it, we get to cancel out the k plus 1, the k plus 1. And so we are left with k plus 1 over k plus 2, and that just happens to equal the right-hand side. Okay, huzzah. Okay, don't forget, make sure that you include your statement, otherwise that's going to cost you in the marking scheme. There we go.